testing a claim about the population mean when the population standard deviation is known. So the objective, we're going to use a formal hypothesis to test a claim about a population mean. So the notation, n is the sample size or the number of trials, x bar is the sample mean, lowercase s is the sample standard deviation, and the population mean of the sample means is the population mean there. The requirements is that the sample is a simple random sample. 2, the population standard deviation is known. And number 3, either or both of these conditions is satisfied. The sample is large, n is greater than 30, or the sample is from a normally distributed population. So, step number 1, you're going to state the claim and the opposite of the claim. Number 2, identify the null and the alternative hypothesis. The null hypothesis is the statement is assumed true until evidence indicates otherwise. The alternative hypothesis is the claim to be tested. There's 3 ways to structure the hypothesis test. We have the two-tailed, left-tailed, and right-tailed. We know the null is always going to have the equality, and it's going to equal to a mean value. And then the alternative for the two-tailed has a not equals, the left-tailed has a less than, and the right-tailed has a greater than. So again, the alternative hypothesis is the one not containing equality, so the alternative uses the symbols less than, greater than, or not equal to. The null hypothesis is a symbolic expression that the parameter equals the fixed value being considered. Step 3, we're going to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Number 4, we need to determine select the significance level. So based on the seriousness of a type 1 error, you make alpha small if the consequences of rejecting a true null hypothesis are severe. The values of 0.05 and 0.01 are very common. Number 5, the test statistic for testing a claim about a mean. So when the population standard deviation is given, we use the z test statistic, where you have x bar minus mu of the sample means divided by the population standard deviation or the square root of n. And then you're going to find the corresponding p-value or critical value and draw your curve and label. So for the p-value, you provided by technology or use the standard normal distribution because it's the z test statistic, or the critical value method using technology or the standard normal distribution table. Number 7, you're going to make a decision. So for the p-value, you reject the null if the p-value is less than or equal to alpha, and fail to reject the null if the p-value is greater than the significance level of alpha. For the critical value method, you reject the null if the test statistic is in the critical region, and you fail to reject the null if the test statistic is not in the critical region. And then you're going to state the conclusion. The original claim does not include equality, and you reject the null. You would state that there is sufficient evidence to support the claim that follows the original claim. Original claim does not include equality, and you fail to reject the null. You would say that there is not sufficient evidence to support the claim that followed by the original claim. The original claim includes equality, and you reject the null. You would say there is sufficient evidence to warrant rejection the claim that followed by the original claim. And if the original claim includes equality and you fail to reject the null, then you would say that there is not sufficient evidence to warrant rejection the claim that followed by the original claim.